Assalamualaikum dear students, I hope everybody is fine. I am Dr. Alives and you are watching YouTube channel Alevelcams. In this lecture we will discuss the polar coordinates. Like the coordinate system, let's say we have a coordinate plane and a point P has coordinate x and y, which is the rectangular or the Cartesian coordinates. So similarly, the Cartesian coordinate, we have many other coordinate system like polar coordinates, cylindrical and the cylindrical coordinate system. But in your syllabus, we will discuss the polar coordinate. The first thing is that what are the polar coordinates of the point P? These are be expressed in terms of r and theta. So we discuss all these in detail, but the question arises here, why we need the polar coordinates. So in this lecture we also discuss why the polar coordinates are necessary, but for the time being we will discuss how it works. Let's say P be a point with x and y coordinate x and y. You can consider, if I represent this point P in a polar form, it will be represented as r and theta. So consider this is an origin. In the coordinate system, this is an origin, but in a polar coordinate system, it is called pole, and the x-axis is called the initial axis. So student, from origin to the point P, there is a distance which is known as r. So r can be written as x square plus y square square root, or you can write the distance between 2 points, understand, which is equal to x square plus y square. Since distance is always positive, so it means r is always positive or greater than equal to 0, is non-negative number. Theta be the angle. So if I rotate theta at the angle 360, you will get the circle of radius r, understand. So student, it means whenever you want to discuss the polar coordinate, every point lie on a circle of radius r, where r depend on the distance between the point and origin. If point is far away, r will be larger. If point is closest to the origin, r will be the smaller. So every point lie on a circle, so it depend on the theta. Here the theta is this one. Let's say you take another point P dash with x and x1 and y1, then its polar representation is r theta 1. The distance is fixed r, but here is theta, this angle will be theta 1. So you will have to see that at the point that lie over the circle, it makes an angle theta or theta 1 with the initial axis. That is the whole story behind it. So one more point is that as we have do this sketching in the polar coordinates, let's say you have an expression y equal to f of x. Here you substitute the value of x and you will get the output y. But when you have the polar coordinate and r be the function of theta, then you substitute the value of theta and get r. This is the important point that you have to understand, will be helpful for the sketching. For the understanding of polar coordinates, we solve an example. Let's say we have a polar coordinate 3 pi by 3. So student, it tells us from pole at angle pi by 3 means 30, 45, 60. This is pi by 3. This is the point at distance 3. So let's say this is the point A. So this point A is just at this with distance 3 and angle pi by 3 with the initial axis. So the theta is called the argument, also called the argument. So student, let's say we have another point A1 with minus 3 and 4 pi by 3. So student, you can see that this angle will lie over this one. When you add pi from here, you will be at this position and distance is 3. So A1 is 3, 4 pi by 3. So student, you can write the point A as 3 pi by 3 plus 2 pi. If you add 2 pi, what happens? You will have a complete circle and you have this same point. If you add here 4 pi, what happens? You have one more point. So for the 2 pi you have one point anti-clockwise. For the 4 pi means the even multiple, the how many points you have. Now student, we discuss the relation between the polar coordinates and Cartesian coordinates. So let's say we have a point P with coordinate x and y. This is the x distance and it is y distance, this is r. So you can write from here y over r is sine theta, x over r is cos theta. So you can write from here y is r sine theta, x is r cos theta, where theta can be written as tangent inverse y by r. This is the relation between the Cartesian and the polar coordinates. So means if we have a polar coordinates, we can convert it to the Cartesian, and if we have Cartesian coordinate, we can convert it to the polar coordinate with the use of this relation. So let's say we have a point 3 minus 3. Let's say this is a Q point. This point lie in, let's say, this position. This is point Q minus 3 and minus 3. So student, the R is defined as 3 square, 3 square, 3 square root 2, and theta is defined as tangent inverse minus 1. So it will be minus pi by 4. Sorry, minus 3, the point Q lie in third quadrant. Student, let's say you have a point P in any of the quadrant. The angle that you will measure, let's say the point S be any point, and the angle you measure must lie in fourth to first quadrant. Maybe your point lie here, here or in the fourth quadrant. Your angle always be in first quadrant or in the fourth quadrant. So if the point in first and fourth quadrant, then it is okay to choose theta from here. But if your point is here, you have angle here or there, you are here, maybe your angle comes here or there, then what you have to do, you have to add pi or 2 pi or subtract pi so that you can reach to your desired equation. So for example, we have a point S has coordinate minus 3 and 3. So means your point S is here. So the angle will be minus pi by 4, means your angle is here. But we need to approach here. What we will do, we add pi in the theta, so angle will be pi plus theta. Understand? And let's say your point T, which is minus 3 means you are in the third quadrant, and the angle you measure will be pi by 4, means your angle is here. So you have to approach at the T. What you will do, you will add pi plus theta. Understand? If you add pi, then you will be at your desired equation. But here is another term which is known as principal polar coordinates. What is principal polar coordinates? For the principal polar coordinate, we have to assume theta always from minus pi to pi included. You know that here is angle 0, it is pi by 2, pi, 3 pi by 2 and 2 pi. I measure this angle anti-clockwise, but for the clockwise you have minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi. Understand? So for the principal polar coordinate, theta is always lie minus pi to pi, means you are starting from here and have a complete circle up to pi. The point is to be remembered here, there is a barrier, because minus pi is not included. So it means you cannot cross this barrier. Let's say you have a point S with coordinate minus 3. Minus 3 means it lies somewhere in the third quadrant. The angle you measure here is pi by 4. Means angle is here, which is theta equal pi by 4, and you have to come here. So you should add pi to come here. It is the general polar coordinate. Means if I write down its polar coordinates, it will be 3 square root 2 5 pi by 4. But if I write down its principal polar coordinate, I cannot choose this way to move from here to there, because there is a barrier and I cannot cross it. So it means the another way that I have to choose to reach at this point. So the principal polar coordinate r is 3 square root 2 pi by 4. You are adding pi clockwise, so it will be minus pi. So pi by 4 minus pi is minus 3 pi by 4. Understand? This is the principal polar coordinate. This is the polar coordinate of the same point minus 3 minus 3. That is an important point. You must keep in the mind there is a barrier on minus pi that we cannot cross, but we have to reach the point. So we have another approach. We can move clockwise to reach at the point. So student, for the next lecture, stay with us.